Yes, student. Now, today we will see what is the example of the second normal form in detail way. But before that, just let me have some idea about the first and second normal form in simple way, as we have discussed many times. So I will not speak again more detail about the first and second normal form because we have already discussed this part. Normalization, as I told you, to eliminate the or minimize the problems that occurring due to the redundancy. That is a good point. Our students are told to us. And we have to design the good database instead of the bad database. So decomposition we have to apply, and here we have to understand the lossless decomposition should be followed. So after decomposition, if we try to compose all the uh, tuples or all the columns, or we try to merge, definitely our information should not be lost. And if it is happening, then we are following the lossy information, or we can say lossy decomposition. That should not be happen properly. So we must have the loss decomposition, and this part we already discussed. Now, when talking about the other part, as I'm speaking the first normal form, you people are required to understand the fundamental part of the first normal form properly. So first normal form means whatever the information we have, that is a first normal form. But the some point we have to keep in mind properly, the no composite attribute and describable property. It means just like the two different columns does not following your key attribute. And if it is having, then we are not part of the first normal form in our relation. So a first normal form should be in the first normal form. That means that it should be, but every relation is keep including the database scheme in the first normal form. So simple one key point we have to understand the first normal form. Whatever we have in the relation, that is should be by default in the first normal form. But the key or the any kind of the composite attribute we must not have. If you are having, then we are not putting the first normal form. That is a simple thing we have to keep in mind while learning this one. So whatever example we have in our real life situation, any table that will be the by default the part is the part of the first norm form. So this is already seen. Now let me just give some idea about the definition part. I have already explained this definition, but I am giving the 2 minutes more to explain this definition once again over here. A second normal form is saying to us, and it should be in second normal form. It should have the first normal form by default plus, or we can say in additional terms we can add over here. All the non-key attributes are fully functionally dependent on the key attributes. That was a point you have to keep in mind. So in your relation, you must be have to identify the key attribute. That was my point. Suppose we don't have a primary key or any kind of the key attribute, then we have to determine the first normal form, we have to determine the second normal form, we have to determine the key attributes. So that is the point you have to understand. So first we have to identify the key attributes. And after determining the key attributes, if we are finding that if we have the multiple or more than two attributes which are making to our relation as a key attribute, so we can say the key that has a more than one attribute, then no non-key attributes. That is the point. No non-key attributes should be functionally dependent. No non-key attribute should be functionally dependent on the part of the key attribute. So that is the term we have to keep in mind. So we will see this concept with a simple way. And this is the point we have to understand properly. This is the dependency diagram. As I told you, the dependency in our relation, as we have seen the student relation, can be made by the three different manners. So we have seen this concept. Dependency can be done by the different attributes on the particular attribute. So here, phone number and major can be depend on the name. Yes, of course, it could be depend. Course is determinant to, or we can say the professor information can be depend on the course. So professor will be depend on the course, of course, because which course I, as a faculty or as a professor, I must share to the student. So I will be depend on the course detail as well. And name and course will be the determinant to the grade. So grade can be depend on the name and course. Definitely, this is the point. So after understanding these three different points, we have our example. From this point, we have to start the class to understand what is meant by the second normal form with the real life situation or with an example. Let's move to this point right now. So in the student relations, we are following the same example. So we will touch only those parts which are following by our previous classes as well. So student relation in the second normal form, we will see this slide here. So student information could be the one kind of relation and which is consisted by the name, phone, and major. So as I told you, name and name and phone and major will be the one part of the our relation. Why? Because name and phone and major, these are the two important attributes that can depend on the name. When talking about the grid, so grid can be depend on the name and code. So name and code and grid will be a part of the one set. So we can say this set is represented by the entity, and or we can say a result, or we can say table. Or relation can have the multiple attributes. So here we have the name, codes, and grade, because grade is depend on the name and code. So what I'm doing over here, you can observe over here from the student relation, I'm just making the decomposition actually. The first point you have to keep in mind, I'm just decompose my relation into the three different relation to avoid the duplicacy or to minimize the redundancy. That is the point we have to keep in mind. And professor and course will also having the dependency. So professor depend on the course, so the course dependent to professor. So this could be the one kind of the relation. So here we have the ct, that is the course title. Okay, ct means course title, and result we have this point right now for measuring the grade. And student information means personal detail of the student, that is the name, phone number, and what is the subject he or she has been updated so far. So our relation will be decomposed into the in three parts. Yes, of course, we are dividing. So that is the point we have over here. So by combining these three relation using the common attributes, okay. So by combining these three relation, we are getting the same and original result as we have seen the previous part. So we can say we are calling the lossless decomposition. So what we will do, what we will do. So I'm just drawing diagram over here. First, we will compose these two relation. So in this case, we have the common attribute. We can say the name. Name is a common attribute. Okay. And if we're talking about the composing of the these two relation, you can compose these two relation. So here you can observe what is the course will be the common. Okay, so that is a point you have to keep in mind properly. While student information and course CT, this cannot be combined. Okay, so we have to find the common. So that is because student information and CT does not have the common attributes. If it is so, so we can do. So by combining these two relations, by these three relations, by applying the natural join, so you will be able to see we are getting the original relation or original table. Then we have the lossless decomposition. So that is the point we have to keep in mind while learning the normal form properly. Now, so far everything is clear. Any doubt so far you have, so please you can ask me right. Just tell me any doubt so far. Yes,
Sir,
any question? Yes, tell
sir,
me.
in lossless decomposition, the common attribute records should be unique.
See, in after decomposition, you're trying to compose the your relation to get the original relation. So if you are thinking that you have chosen the right attribute to compose the relation in a single relation, then you can do the common attribute should be in the lossy decomposition or lossless decomposition. But the point we have to keep in mind while composing, you must have a common attribute. So you are using the common attribute. The point you should be keeping in mind right now, you have selected the particular attribute by which you are just trying to get the original attribute, original relations. Then you can say, I'm pulling the right now the lossless decomposition. But there is no guarantee after the composition, you after the composing or while composing the our relations in a single relation, there is no guarantee you may have the original table. But you are having the original relation, then you are having the loss of decomposition. So while filtering, that was my point. While decomposition, you have to choose the appropriate attributes. So phone number and phone and major cannot be the common attributes. That is a good point you have to keep in mind. So student information and result, I'm just using these relations from our original relation. So you have to identify which column I must or which attribute I must take to as a common attribute. One cannot be. Okay. If I'm using the phone number in the result relation, then what will be the sense of that part? There will be no sense because grade or any kind of the information doesn't will not be depend on the phone number information. Same for the measure. But name is the one attribute that can say us to it can be the common to define the grade of student along with its course. So that's the reason we are choosing the name as a common attribute. So I was my point here. If you are getting the original relation, then you are following the lossless. But if you are getting the thing some extension or increase or decrease way in the tuples, then you can say you are having the lossless. But there is no guarantee while composing you will get the same. But it depends on the choosing the appropriate attribute. So here we have only chance we can choose only the name attribute between the student information and result information real relation. Same thing, result and course. So here I'm choosing the name of the student inside the course title relation. Then a student can be a part of the many professor or many student can be the part of the many professors. So duplicacy will be applicable there, and that is valid. So we have to determine some appropriate attribute to distinguish our result, our information by the proper nature. So we can at least avoid the redundancy. So selecting an attribute basically a, a concept. But this concept is not based on the mathematically. It is determined by the functional dependencies. That is my point. So in the functional dependencies, what we have seen? We have seen the what is the idea we have to use to determine the our attribute properly. If you remember the lossless and lossy decomposition, then where we have seen instead of the AB, I'm choosing the AC relation. So definitely C was our common attribute, and I was getting the multiple tuples unnecessary. So that was making the lossy decomposition. So that is the basically an art choosing the appropriate relation. But here it's saying to us what is the attribute you are choosing to get the proper result. So relation should be in the second normal form to avoid the our duplicacy in the our tuple. That was my point. But here you can observe over here phone number and measure are the depend on the name. So phone number and measure are the non-key attribute that depends on the name. Okay, so this is the point you have to keep in mind. And in the second relation result we have, so course and grade will be depend on the name. So that is the point. Or in the name and course will make a key attribute in the result relation. So grade will be depend on the these two attributes, that is name and course. And if I'm choosing about the course title, so professor will depend on the course. Our relation will be in second order form while decomposing. But you have to use the appropriate tuples or you have to choose the appropriate attributes. That was my point. But if you're getting the original relation, then you are following the lossless. But you are not getting, so you are following the lossy decomposition. That was my point. But see, here we will not talking about the much about the losses or lossy decomposition. But in the normal form is saying to us, if you are choosing the appropriate attributes, then you are getting the actual relation as we have seen after composition, then you are following the losses. But there is no guarantee because here we after evaluating or after applying the join operation, then we will see. So before that you are not allowed to say sir it is a there is a guarantee. So there is no guarantee, but at least we can say. But before that you have to apply the concept. If I'm decomposing, then after decomposing the student information will be in the first normal form. Yes, it is first normal form. And phone and major will depend on the name. Yes, it is the possible. Same thing in the result relation, name and course, these are the two attributes. So grade will be the our non-key attribute that can depend on the our key attributes, of course it is possible. And here course and a professor. So a professor can have the multiple course. Okay, that was my point. A professor or same professor can have the multiple course, but the professor can have the a professor can have the duplicacy or vice versa is also possible. The multiple course can be handled by the many professors, so that also possible. So professor will depend on the course by because professor will try to offer the course so from which he or she has to opt. from this point. So here we can say the after decomposition our relations will be in the second order form, and that is a point. Yes, now tell me. We have another example, don't worry, but we have to understand this fundamental point. Yes, tell me right now.
Got it, sir.
Okay. So, see, this is a point. What I am speaking, what I have spoken over here. So, the summarized point here in the form of the diagrammatic nature. So, student information, we have the name and phone number properly. So, name to phone dependency and name to major dependency are being preserved in the student information relation, and that is also possible. Phone number I can take as a key attribute, and major I can't take a key attribute because phone number could be possible in real life situation. Nowadays, it is also possible, and that is also possible. But what is the problem? Suppose I don't have a phone number, I don't have a mobile number in this situation right now, or my mobile is uh, just having the bad network. So a friend can communicate to my father contact number or my mother's contact number. So at that moment, what I having the multiple phone number. So, but in the case of the key attribute saying to us, you are not allowed to have the multiple entries or multiple values. You can have only the single values. So that is reason in practically that is reason phone number cannot be. So we have to choose the appropriate term properly. You can make right now, you can update your information by that part, you can do. But after creating this point, phone number has a key attributes. So how you can relate such phone number attribute to the other part, just like the result, just like the result. So in the result, if you're trying to put the phone number as a part of the key attribute or composite key attribute, you can do, but that will not be the feasible solution. So you have to just think a little bit by your brain or your logic. You have to update the thing properly. So that is the reason. Okay. So next mean we have the course to professor is being present in the course title relation. So that is the point. So course is determined to the professor we have. So this is the point. Next. Name and course number is to grade is being preserved in the result relation. Yeah, of course we are having over here, and we have seen this point right now. So this relation can be distinguished into the second order form like this. So here we have this relation in form the second order form. Now here we have an example, and I would like to explain something with help of the example. Then you will able to understand the concept in simple way. Roll number, name, department, year, and hostel we have. So roll number we have all the values. So you can observe over here roll number is represented by the unique data. Yes. Name we can also have the name. We also have the duplicates, but there is no guarantee. If you have the large pool of the data, so row name can be repeated. Department of course could be repeated undoubtedly, so there will be no issue to discuss this one. Here will again we have the duplicacy. Yes, of course we can have. And hostel name we have so hostel name can also belong to the duplicacy. A student can have many students can be a part of the same hostel, so of course it is also possible. Many students belong to the same year, so it is also possible. Many students belong to the same department, yes, of course it's possible. And or but many students cannot have the same roll number. That is it. So we have to identify the or we have to decompose our relation as per the second order. This is a simple question. Okay. The question is problem is clear right now. Just tell me right now. Problem is clear. Problem is clear. First, let me know right now. The problem is clear.
Yes, sir.
Yeah. What we have to do? We have to decompose our relation. This relation is given over here in form of the second order form. So let us understand this point with help of the its values. Step number one. Roll number uniquely determine the name. Just tell me yes or no. It is also possible, so we can say yes. Roll number uniquely determine the name. Yes, of course. Roll number uniquely determined by the department. Of course, it can be also determined by the department. So with help of the roll number, I can easily determine that who is belong to the which department. So that is the point we have the good point. Yes, roll number can also determined by the years. Of course, we can say. The roll number also can determine by the hostel name. So we can easily determine in which year student belong to the and who is belong to the such hostel number. So we can easily identify by this part. So roll number here, what we are observing over here, the roll number is be a part of the key attribute, or it would be the key attribute. So yes. So this relation is in the second order form. Yes, I'm saying here this relation is by default in the second order form. Why? Because no no composite attributes are determined by the one property. Okay, so this is the true. It means my relation will be in the first normal form. So in the second normal form, I'm saying over here. So second normal form definition is saying to us the relation should be in the first normal form, and all non-key attributes should depend on the key attribute. So how you can say this is a relation is a part of the second normal form? Can anyone tell me right now in a one or two statement how this relation be a part of the second normal form? Can you tell me? Yes. Can you tell me right
Because
now?
there is no composite key attribute. It
Okay.
determines the non-key attribute. And
Okay.
all the non-key attributes are dependent on roll number, where roll number can be a primary key or key attribute.
So what are the non-key attributes? Can you tell me?
Name, department, year, hostel.
Okay. Super. See. So here we have the roll number as a key attributes and non-key attributes we have name, department, year, and hostel. So we have this diagram right now. Yes, of course, you are on the right track. So this is the statement is saying to us now we are proving the our relation will be in the second normal form. So we are following this approach. Yes, of course, we are on the right track. So all these are the functionally dependent each other, so determine each other. So of course, so dependency existing between the year and hostel. Yes, of course, is also possible. Hostel and year can also have the function determined. Yes, of course. In which hostel does number of students belong to the in which year? So we can consider this point. So these two relations, these two attributes can also say the function determined. Yes, of course, this is also possible. Okay, so dependency diagram. Let me explain this thing. Dependency diagram. Key attributes: name, department, year, and hostel. So all these are the depend on the our roll number. So we have the key attribute. But we are observing over here, if I'm talking about the year and hostel, then redundancy of data we have. Redundancy of data we have over here. Then what is the problem actually? Redundancy of data can we have? Yes, of course, in this case we have the redundancy of data in case of the year and hostel. So this is what actually. So let me continue this point right now. So there will be the insertion of dates and date anomalies. So that is a big problem. In the second normal form, we are saying duplicacy can exist while applying the insertion, updation, or data anomaly. So that also possible. Yes, we're talking about the hostel, year, department name. All these data are depend on the second normal form. That is the key attribute roll number we have. But duplicacy can also exist over here. But as per our definition, we are using the normal form, so we are trying to reduce the duplicacy. That was the main point. So this can be avoided or this can be removed by the next normal form. But before jumping to next normal form, you can also observe over here, Kaveri is a hostel name. And in this year, we have the second year students and same the Ganga is a hostel name in which we have the first student. So duplicacy is also available over here. So that is the point we have to avoid such thing by the third normal form. So this relation will be the part of the second normal form only. This relation cannot be considered as a part of the third normal. Okay, that is the point. You people are required to understand this thing properly. So having seen the relation, you have to identify the relation in which kind of the normal form the particular relation is following. So that is the point. So you can observe over here is in this case anomalies can be occur. Okay, so it is clear to us right now. This concept is clear. This relation will be part of the second normal form, but this cannot be jumped into the next level normal form because of the this drawback, the duplicacy we have.
Yes, sir, clear.
Okay. Yes, good. So let us see one more example and see. So I'm just sharing the one more example over here, and I'm expecting the people speak the answer properly. So let us assume a school can store the data of the teachers and subject. they teach. In a school, the teacher can teach more than one subject. So this is the relation we have. Teacher ID, subject, and teacher age. So in the given table, non-prime attribute teacher age is depend on the teacher ID, and which is a proper subset of the candidate key. A subject cannot be depend on the teacher ID. Yes. So you can see over here. But that's why it violates the rule of the second norm. So if I need to decompose my relation, then how I can decompose? So can you tell me subjects and teacher is? So teacher is can ID depend on the teacher ID. Yes, we can say that's why it violates the rule of the second norm. So how to decompose this relation? Can anyone tell me right now?
Sir, in first table we can have teacher ID and subject, and in second table we can have teacher ID and teacher age.
So subject and teacher is are the part of the key attributes. So these two attributes can depend on the teacher ID. So teacher ID with primary key. So of course this is the second norm we can see. But here we are founding over here that the teacher is it depend on the teacher ID and which is a proper subset of the content key. But why it is saying to over here? Why it violate the rule of the second norm? So that this was my question. Why it is violating the rule of the second norm?
So because all the non key attributes should be dependent on key attribute, but subject is not dependent on teacher ID.
Yeah, that is a point. Because there are the many subjects which can be offered by the many teachers. So just like myself over here, I'm teaching the database management system, and the other faculty is also offering the same course. So course is not dependent on the or on the teacher ID, and that is the point. So here we can have the duplicacy. So that's why it is violating the rule of the second one. This problem should be clear to all, and this kind of the question may ask in the examination for to provide the confusion. Okay, so I'm speaking once again, focus on the fundamental part properly. And first, you have to keep in mind the definition, and then you have to identify the relation. Of course, without the data, you are not able to assume the thing properly. If it is not given, then you have to assume the data and to determine the second normal form, third normal form as our requested question. So that is the point. So what we will do, we will divide or decompose our relation, teacher relation into relation. So here we have the answer. So to convert the given table to second normal form, so we can decompose into the two tables. Teacher is a non-key attribute that can depend on the teacher ID. So yes, it is true. Subject is also depend on the teacher ID. Yes, of course we can do because by applying the by applying the teacher is and subject is, we are not able to see the thing properly because a teacher who is offering the course and the is may same or different. So duplicacy can also occur over here. Why? Because subject name I am offering DBMS. Same age kind of the faculty can also over the same course. So in this case, you can observe over here, subject name and teacher age may have the same value, and here we have the duplicacy, just like here. Like Kaveri and Ganga, and we have the multiple times here and here again multiple times. Same teacher's age here you can observe over see here. Teacher age we have that 30, 38. Okay, so there may be some chance where the chemistry is offered by, just I can write here short chemistry, which is offered by the 30 is, and another ID. Suppose I'm just putting the 93, 30 region, and you can also observe over here. Here we have the ID, and here we have the this. So having seen this thing, we can say here we are having the duplicacy. So to avoid the duplicacy, what is the better idea? It is better idea to decompose the relation into parts to relation, or if you have, you can extend your relation in more ways, then you can extend. So what I'm doing over here, I'm just dividing the our relation to parts. So you can observe over here, teacher ID, here we have the uniqueness, and this teacher is depend on the teacher ID. Yes, of course. So this is the duplicacy we are trying to avoid. And next we have the teacher subjects. So a teacher, multiple teacher can have the many subjects, yeah, possible, or many teacher can teach the many subjects. So it is also possible. So unlike over here, this teacher ID will teach the two subjects. One is a chemistry and biology, and same thing. It is also possible. So this is the point you people are required to understand properly. And after applying the natural join on these two relation, teacher details and teacher subjects, if I'm applying the natural join teacher detail and teacher subject, I must have the owner relation, that is teacher. If I'm having, then I can say I'm following the lossless decomposition. But if I'm having the lossy decomposition, there's no guarantee after natural join. If I'm having the lossy decomposition, it means I'm not following the good database system. If I'm not having the good database system, so normalization will fail at that moment. So I'm requested so many times, please allow always no lossless decomposition. So you have to choose the information properly. Teacher ID will be the our key attribute over here, in which the non-key attribute can depend on this part right now. That is the reason we have to choose the appropriate data properly. And after decomposition, we are getting the thing properly. So teacher ID is common, so that's why we can say it could be the our key attribute. Okay, it doesn't mean the primary key, but it is represented by the key attribute. So we can say, of course, it is key attribute. Okay, so this is clear to all right now. The fundamental concept is clear. Second on form.